Good evening. Now, 8 questions we have already seen in last video. Now we will go to the remaining question of assignment number 8. So we have question in a list column 20 diameter boards are used for its connection. In this case, the minimum width of lacing of flat should be. Now we have width of lacing bars and that is given not be more than 3 times, means minimum we require that is 3 times the nominal diameter of the bolt. So in riveted or bolted connection, the minimum width of lacing bar should be more than 3 times the nominal diameter of the end conductor. Now more than 3 times. So we have that is width. Not we cannot take equal to. So more than 3 times means we can have this as 20 into 3. And that is 60 millimeters. So it is mentioned more than 3 times. So it should be 70 millimeters. So answer should be answer D. So we have answer D. More than 3 times, not equal to. They have mentioned not more than or equal to. So we cannot take 60 mm. We have to go 70 mm. Then we have two ISMC 250 placed back to back, single column. The lacing bar solid flat of thickness 10 mm. Thickness is given. Inclined to 45 degree from the longitudinal axis. Find the minimum value of other two dimensions, that is length and width of lacing flat. So diameter of bolt is 16 mm and gauge length 45 mm. So now width of lacing bar we have seen 3 times. Now diameter of bolt is 16. So 3 into 16. So we have 48. So now we can go width of lacing as 50 millimeters. So we can write here width equal to 50 millimeter. Width of lacing equal to 50 millimeters. Then we have next length of lacing. So we know length of lacing, that is distance. We have distance between centroid upon cos of 45, or we can write it as into cosec of 45. So distance between centroids. So we have given gauge length is given 45 mm, and we have these are placed back to back. So when they are back to back, then we have distance between centroids. So directly we have spacing plus gauge length. So we have this is gauge length. So 150 plus 45 plus 45 both sides. So it will be 240 mm. Then L effective distance between centroids upon cos 45. So we have 240 upon cos 45, 339.41 millimeter. So we have this as 340 millimeters. So we can write L effective. Actually, this is not L effective. Directly we can write L also, because L effective we have to decide, that depends upon your connection. So we will write it as L equal to. So we have L equal to 340 millimeter and width is 50 millimeter. So we have this as option A. Then we have two ISMC placed back to back with a spacing 190 mm and single lacing system with an inclination of lacing bar of 45 degrees. If the gauge length 50 mm, the minimum radius of gyration. So we have seen minimum radius of gyration, we have T by root 12. So now minimum thickness, length of lacing flat upon 40. So we have the minimum radius of gyration that was asked. So minimum thickness, because formula is T by root 12, that is thickness upon root 12. So minimum thickness for single lacing, we have length of lacing bar. This also we have seen distance between centroid. into cosec 45. In last example, we have seen upon 40. So this comes 10.25 mm. So T by root 12. So put T 10.25 and this value comes 2.96 mm. So we have option that is option is D. And then we have last problem that is 2 ISMC 350 placed back to back with a spacing 200. Again back to back 200. Single lacing. Inclination is 45 degrees. Gauge length 50. Then the design compressive stress. So now we have distance between centroids. So we have this value. L effective 300 upon cos 45. So this I will say L. Then L we have 424.26 millimeters. Then minimum thickness, length of lacing plate upon 40. Then 424.26 upon 40. Then minimum thickness 10.61. Minimum radius of gyration T by root 12. 10.61 upon 12. So 3.06. So lambda we have 424.06 upon 3.06. Effective slenderness ratio, length upon radius of gyration 138.65. Class C. And then in class C we will have FCD. So value we have that is 74. So we have to consider between 70 and 80. So we have this value 70 and 80. So this comes 67.29 Newton per mm square, because this is table 9C. And then you can see 67. So we have option that is C. So now we will stop here only. So likewise, you have to solve the problems related with your assignment number 9. Now we will stop here. Thank you.